this altitude is perpendicular, BD is perpendicular to the side, which means it's creating right angles. So to figure out what reason do I put here, which one of these reasons is talking about right angles? 1, 2, 3, or 4? 3. So that's going to be our reason for number 3, our statement for number 3. BDA and angle BDC are right angles because we have an altitude, and altitudes make right angles. Okay, so that's our statement. That one makes the most sense to me. I know what an altitude is. I know altitudes make right angles, so I'm probably going to put the one that's talking about right angles there. Then in this next one, we haven't seen this before, but it says all right angles are congruent. Right? Well, I just said that these two angles are congruent. Then it's saying about how right angles are congruent. So which one of these next ones makes the most sense to put? 1, 2, or 3? 1. Yeah, I just said that these two angles are right angles, then it's talking about right angles being congruent. So more than likely, this guy right here, that makes the most sense to me. The reason why, what the heck happened? Where'd it go? Okay. The reason why we're writing that is because what do all right angles equal? Every single right angle equals what? Equal 90 degrees. So every single right angle equals 90 degrees. That means every single right angle is congruent to each other. So these two things go hand in hand. Whenever you're filling out a proof and you're stating that two angles are right angles, immediately you're going to set those angles congruent to each other, and that's your reason. So whenever you write or you're told that angles are right angles, this is going to be a statement of reason in your proof. You're stating that they're congruent, and that's the reason. Okay? Then I look here at my statement. It's saying that DB is congruent to DB. Well, what do we say? What do we use? What reason? Whenever we have something congruent to itself. What's our reason? What is it? Reflexive property. Every time you have something congruent to itself, it's a reflexive property. Every time. Okay? The reason is, look at the type of triangles. What are these triangles sharing? They're sharing a... They're not sharing it. They both have a right angle, but they're sharing it. They're sharing a... the side, right? This is what we call shared side triangles. So whenever they're sharing a side, or the side's going down in between, that shared side is always congruent to itself. They're always congruent to itself. Every time. Shared side triangles, if you want to make a note again, shared side triangles always means reflexive property. Every time. That shared side is congruent to itself. Every time. So now, because we marked our diagram, we know which reason to use. And we only know two reasons right now. It's either one of these two, side, 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 or side angle side. So did we mark 3 sides congruent, or did we mark 2 sides with an angle in between? 2 sides with an angle in between. We have a side, then we have an angle, side. Side, angle, side. So that's going to be our reason. Questions over that? Nope. I think that's all the notes.